All right, so this would be A minus B, quantity squared. What's it equal to? Somebody recite it that knows it. A squared minus 2AB plus what?
Square.
If you don't know the shortcuts, that's where you can run into problems. And those shortcuts are not going anywhere. Maybe that's why math is racist. We expect just too much. There you go.
Thank you, sir.
You're welcome. All right, now let's get back to
Facebook.
I'm just going to have to, no, I can't, I can't pull up Facebook because somebody will complain. So here we go. 5.1 is exponential functions. I don't remember what we talked about so far, but probably going to talk about what's called the one-to-one function. Did we talk about that? And inverse functions. So I can't remember what we've talked about, and I get y'all mixed up with the 110, so I'm just going to get everybody synced so I won't have to worry about it. Here is a y is equal to 2x. Now this is where you need to put this in your family of graphs. So go pull that notebook up. When you have an exponential function, it's going to look like that. So y is equal to, and just use 2 to the x. It's always going to be an increasing function. What is it doing in the first quadrant? It's increasing. So when you're dealing with business and marketing, you're going to have a lot of functions that are in the first quadrant. And that's pretty much exponentials and logs. Unless you have a negative exponential, and then that's going in the opposite direction. So mostly all of your formulas are going to be in the form of y is equal to 2 to the x or y is equal to the log. So make sure you add that one to your family of graphs. Now, of course, if I give you 2 to the x plus 2, the x plus 2 is a horizontal shift. And then if it has plus 8 outside of that, that 8 is a vertical shift. And you're probably going to see a couple of those. So make sure you write that one down. The domain of this function is negative infinity to positive infinity because you can put anything in as an exponent. There's the rule for an exponential function. F of x is equal to b to the x power. All right? And there, write this down, this is the negative x function. So the negative x function, I'm going to do it in red. Y, really? Hold on.
Your ports are racist.
Yeah. Y is equal to b to the negative x. It's going in this direction. And then, of course, we'll do that one in black. Y is equal to b to the x is going in this direction. So you need to have two family of graphs, one to the negative x power and one to the x power. You need to know how they look, and they all cross at 1. This right here is 1. 0, 1. Because when you plug in 0 for x, you get something to the 0 power, and what is anything raised to the 0 power? 1. Anything raised to the 0 power is 1. Next. What is that negative 3? Somebody tell me what that negative 3 is.
For, no.
Horizontal horizontal shift to your, that's right, class.
Horizontal
Thank
shift to
you.
the right.
To the right. Now, if I had a +4 out here,
Be to
what
the
would that
left.
+4 be? Vertical
left,
shift
four.
up 4 places.
Oh.
Okay? So remember, the things that you learned in Unit 2, Unit 1 and Unit 2, you're still applying. If the number, if you have a function, and that function is an exponent, f of x is equal to 3 to the x minus 2 plus 7. This is the actual function. Is the 2 connected to the function? Yes. So therefore, this is the horizontal shift. This is the what? Vertical shift. And of course, this is A, so it's going to be more narrow than the 2. So we know this one's going to have a horizontal shift of 2, 3 to the right. There it is. So I'm going to erase my board and let you see, okay? Understand that you're moving 3 places to the right. And where is the origin on your, where is the point that never changes? The point that never changes is 0, what? 1. So that's technically like your origin. Yeah. So whatever you move, it's going to be based on this point right here. 1, 2, 3. Because you can't use the origin down here because you can't tell where it is. So you're going to use on an exponential function, you're going to use that point right here to move up or move left or right or move up and down. That's what you're going to use, that y-intercept. So that's a good, so of course next they're going to add the what? The vertical shift. They should. There's the vertical shift. I don't write it like that. If I'm going to write it, I'm going to write it the way that you've been following it the last 2 units. Y is equal to 2 to the x minus 3 plus what? Now we've got a, this is your parent graph. So now we're going to move 3 places to the right. I'll do that blue. So 3 places to the right. 1, 2, 3. And 3 places up. 1, 2, 3. So now, if I could, I wish I could, pick up, if I could pick this up right here, and it won't let me. If I could pick that up, I would move it, and I'll just do it in blue. Like that.
What changes?
I'm sorry, what?
What changes if that's okay.
Then that would be 3 places to the left. You would move this dot 3 places to the left and then 3 places up. Now, are these last 2 problems, test questions? Yes. I want you to be able to ascertain sketching a graph just by looking at the horizontal and the what? Vertical shift. So make sure you can do that. Because I'm not going to spend a lot of time in these exponents. The exponentials, I'm going to spend time in it as far as vertical, horizontal, and sketching the graph. Everybody got that? Logarithms is where 80% of your test is going to come from on Unit 3. Logarithms. And that's where the algebra comes in. So I'm not going to spend a lot of time on exponentials. There it is, see? They took this spot and they moved it 1, 2, 3, 1, 2, 3. So that spot is the same spot. Now what does that 4 do? That 4 is going to compress it. Because it's what? It stretches it and it compresses it.
The whole number.
Exactly. Now,
Of course.
And what do you plug in? When you plug in x is 0, what do you get? 1 times 4, which is what?
4.
So now that 1 is not 1 anymore. Now it's what? 4, because you're what? You're compressing it. So A is equal to 4. What was that? Y'all okay? Y'all having convulsions? Y'all need some medicine or something?
No, we're just
Okay.
very.
Now here
dedicated
is a problem. This is more of a practical app. And it says, suppose that inflation is predicted to average 4% per year for each year for 2012 to 2025. This means that an item that costs $10,000 one year will cost blah, 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 blah the following year. So you would raise it 1.04 to the second power right there. This is 1.04 to the first power. Okay? Write the function that gives the $10,000 item t years. So it's going to be 10,000 times 1.04 to the x power. Okay, or something like that. There it is, to the t power. And then graph that. And they may not graph it. I don't know if they're going to graph it. But what would be, yes, the graph from 0 to 13. So your domain here, I did find out how to do that. Wasn't we trying to find out how to put in graphing calculator, how to put in the domain?
Yeah.
Okay, you don't use a comma, you use parentheses, no comma. Okay, so if I wanted to type this one in, hold on a second. I'm going to type it in so maybe y'all learn something. Yeah, even Jake might learn something. Take your handy dandy calculator and type in.
Love you too, man.
Yeah. Y is equal, what was the function? 10,000? Was it 10,000? 10,000. And then 1.04 times parentheses 1.04 to the x power. And I'm just going to put to the x power and then close parentheses. Then I'm going to go parentheses. I did this yesterday. Watch it blow up. X, let's see, 0 less than, okay, less than, what did I say, second math? Okay, second math. Why isn't it? Oh, I hit alpha, sorry. And less than or equal to x less than or equal to 13. Everybody with me? And graph. And it should only graph those, and you may have to find it. I don't know where it is. Let me go to Zoom Fit. What is it, Zoom Fit or Zoom Stand? Let's do Zoom Fit. Zoom Fit, which is Fit.
That's one you could do.
Fit. And it should be just doing 0. It's not. Now, it was doing it the other day. We did it. So I must have something typed in wrong. But I did do from 0 to whatever. It's not doing it now, so I'm a failure. Just keep playing with it. I actually had it working the other day. But that's how you type it in, something like that. I'm not going to get back on that. But anyway, let's get back to this. Oh, you got it to work?
You just got to zoom out further.
Oh, okay. So how'd you do? Zoom out?
I think it is. Yeah, it looks like it stops at a certain point.
Okay, zoom. You just do zoom out one time? Well, yep, mine's still doing, it's supposed to be going from here to 13.
Yeah, it's just zoomed out to the point where it's locked. The X. Never mind.
Okay, something is still not doing it. It's just supposed to show you this right here. So I don't know why it's not doing it, but that's how you type it in. Somebody should have figured it out. All you got to do is go to Google and figure it, but some of y'all probably, that's too much work. And we all know Google is racist, so. All right, anyway, you type in 13, go to the table, you can put in 13 and find out what Y is. Y'all know how to do that. I'm not going to spend a lot of time on that. All right, same thing here. If you want to find Y, you can either find it with the table or you can find the intersection point. So if I wanted to find Y is equal to 13 on that one, or 12, then I would type in here, Y is equal, and I would type in 12 and graph, and you'll see 12 come up somewhere around here. It's not coming up. Why is it not coming up? I still think I'm not out enough. Out. You should get a Y is equal to 12, and I don't know why it's not coming up. But anyway, go to table, go to table, second table, and okay, there's Y is equal to 12 right there. Why is it doing that? That's not what I want. I want X is Y is equal to 12. Oh, I know why. Because I haven't got it blown up big enough. You got to go in, and you got to go in, and go in about 3 or 4 times. Zoom in.
Zoom fit.
Zoom fit. Thank you. Well, zoom. Now I done locked it down.
You done it now.
There. Hopefully it'll show. Okay, there it is. And it should show. It's not. Maybe my calculator's screwed up. I don't know. Maybe it's just not working today. Pendleton, what do y'all think? I ain't even paying attention. They're watching Netflix and Hulu. Heck, 2 more left. Okay, well anyway, I don't know why it's not doing it. Maybe y'all can hit Zoom standard and find out. But that's what they're doing here. They're setting Y is equal to a number and find the intersection point, or you can go into the window and do that. Okay? There it is, plugging and chugging. Plugging and chugging. Okay, write this one down. This is growth. Whenever you see growth, you're going to have E in there. E is also for continuous interest. Write down E is equal to growth. E is equal to continuous interest. Whenever you see the word E, you're going to have continuous growth. And the question asked, it says, if $10,000, and just remember PERT, PDRT, used to be a shampoo a long time ago. Some of y'all don't even remember it, but PERT.
I still use that shampoo.
What'd you say?
I still use that shampoo. Comes in a green bottle.
Yeah.
PERT.
And it's
It's bomb.
P is equal to E R to the T, PERT. E is in your calculator. E is a constant. And this is a test question, and this is also a standardized test question. Whenever you see continuous growth, you're going to see E. Some of y'all that are in business and marketing, listen, Pendleton, I know you don't want to listen to me, but you will see this in the future, especially in my 130. Oh, and I do have 130 listed. I'll show you. Jake, remind me to show you my classes. I got them yesterday, so I got all finalized yesterday. So if $10,000 is invested for 15 years at 12%, what is the future value? Okay? What is the future value? And you plug and chug. I'm sorry, S is equal to PRT. My bad. S is equal to PRT per, because that's the principal. Okay? And 10,000 E to the, and you use your calculator. Now, some of you, hopefully you know where E is. Somebody tell me where E is. It's above your logarithm, I believe. Second is an LOG. So make sure you can type in 10,000 E to the 1.8. Second division?
Yep.
Okay, I thought it was over the logs. Okay, second division. So let me go to the handy dandy calculator. This is such a pain.
Second division.
Let me look. There it is. Second. I thought it was over the log. I can't see this. Somebody look over the LOG or LN. It looks like natural log.
It's I got LN.
Okay, that's the natural log. So here's how you type it in. For those of you that don't have a clue, you type in 10,000, not 100,000, 10,000, and then second E, and then 1.8. And enter. Now that is pretty simple.
Yeah, that's a different model.
Okay? So what do you have? TI-83?
TI-83 plus, yeah.
TI-83 is over the division symbol?
I got TI-83 plus 2, and it's under my LN.
Okay. Well, make sure y'all get the right one. Y'all just suck. Yeah, you must have got that at Jockey Lot. All right. Next. So now you got two test questions.
Yes.
You got a vertical horizontal shift, and you've got graphing questions. That's what these are. Carbon dating. Write that down. You're going to see that, especially in your biology classes. Let me go back one and hit the slide. Okay. This one, they should give you one before this one, though. Nope. They should give you a, well, here it is. Y over initial Y is equal to E to the negative blah, 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 T. Okay? So you need to write that one down because you will see that on a standardized test. Especially, you're going to see them if you're in biology. Any kind of biology. And you got to know how to use E. And you know how to use E because I just showed you how to use E. All right, there it is. Y is equal to F of T, and they solved it for Y. So your initial Y times E to the negative blank T. So if the original amount of carbon, 14 present, in artifact is 100 grams, how much remains after 2,000 years? You would plug that 100 in right there. Right there. And set it equal to 2,000 or equal to 2,000. So after 2,000, you have 78.5 grams. So that's how you solve those. You plug in the 100 and you plug in the 2,000. So make sure, and again, I'm not gonna spend a lot of time on these because these are basically plug and chug and calculator. So Jake, you better ask questions if you don't understand how to plug and chug. Quit watching that. All right.
This is good. This is a good part.
What percent of the original amount of carbon remains after 4,500 years? Well, 4,500 is going to go right there, and you're going to solve for y sub 0. So 58% of the original amount will remain after 4,500 years. Okay? And that's what they did. All they did was plug in 45 and solve. Now this is a constant. Now I just want to make sure y'all understand this, and you need to highlight this. This number right here is a constant. That number is all that is a number. So I don't want you to get that confused with it being an X or a Y. It's not. It is a number. It's the same thing if you was to take pi and multiply by 2. Pi times 2 is 6.28. It's a number. So anytime you see E, that's going to come out to be a number when you plug in what?
Chug.
When you plug in chug, you're going to end up with a number, and that number is 58%. What? So far we're doing vertical, horizontal, and calculator drills. That's 5.1. Let's look at 5.2. Again, I want you to do the homework, but don't worry about it because you'll send in questions and we'll end up doing the questions. That's not a problem. I want to get us to the logarithms because that's where the algebra is. Right now we're not doing any algebra. You're doing calculator drills and vertical and horizontal shifts. So here's where we get into the logarithms. There is your definition of a logarithm. So if you didn't write it down before, make sure you write it down now because there it is. Here it is right here. Log y is equal to log base b of x yields, either way, x equals b to the y. That is the definition of a logarithm. And yes, I've written it down twice for you because at least 3 sections in this logarithm unit depends on that definition. So if you want to just fail 3 of the sections out of 4, then just don't learn that because you're going to have to learn it. Just remember, I use A, okay? Y is equal to log base A of x. X is equal to a to the y. That's the way I learned it. Doesn't matter what letter you use, but just remember, if you go this way, you're turning a exponent into a logarithm, and if you go this way, you're turning a logarithm into a what? An exponential. It's very important that you learn that.
So the top is what?
What do you mean the top?
Like the top right is exponential.
Yeah, this is an exponent. Exponent to a log, log to an exponent. And don't worry, after you do 3 or 4 problems, you'll understand what to do. Okay? And this is the inverse of that, which is really not irrelevant to this, but it's irrelevant to other problems. It's not. The definition of a logarithm, make sure that base, whatever this number is,
Oh, that is the inverse.
is going to be this. Okay? And then the y, you're going to raise it to that power. It'll make sense. They're probably going to do a problem here next. And this is where your journey begins on logarithms. So I want you to rewrite every one of those as a logarithm. Using that definition of a logarithm, rewrite every one of these as a logarithm. Y is equal to... See, when something messes up, y'all laugh. Y'all talk to me. But when I ask y'all to talk to me, y'all don't laugh. Y'all don't do anything. Y'all hate me. That's what it is.
No, we're just zoned in.
Y is equal to log base A of what? X. And that yields what? A to the what? A to the Y is equal to what? X, right? I might have used B to the Y, whatever. So what does this look like? Well, this looks like a to the y is equal to x. So now I rewrite that, and I put my y. My y is equal to what? 2. So that means 2 is equal to log, what is my a?
4.
Log base 4 of what? 16. And I've just written a exponent as a logarithm. Okay, good. All right, so this one, we've got a to the y is equal to x. So that means y is 1 is equal to log base 7 of what? 1/7. And that is a property that if you have a reciprocal base, see the reciprocal? It's 7 over 1. What's 7 over 1 times 1 over 7?
1.
1, and a log of 1 is 1. So that's a property right there. Okay, over here, a to the y is equal to x. Go over here, y is 1 equal to log base a of what? 8. And when these two are equal, it's equal to 1. Over here, a to the y is equal to what? X. So what's my y? Y.
Y.
What's my a?
R.
5. Log base 5 of what? X.
A. Or X, I mean.
Yep. Now, this is the number one reason you need to use the definition. Number 2 is when you're rewriting. Number 3 is when you're solving equations, which is going to be like 5.2, 5.4, and 5.5. So you use the definition of a logarithm in 3 sections. This is where you need to be digging in and doing these, because if you don't do them now, you're not going to do them. So now you can go the other way too.
Damn, aren't you like 7 foot or something?
What?
Oh no, I was just asking if he was like 7 foot because like his head touched the top of that door when he walked in.
Oh, I thought y'all were talking about something mathematical. I'm sorry.
I mean, if you're that tall, you can't help to notice.
Log base a of x
7 foot,
yields
Jake.
a to the y is equal to what? X. So let's go over here, and this is y. Log base a of x. So what's a?
2.
A would
To
be
the
2.
Is equal to 32. Is that correct?
Yep.
Yes. 2 to the 5th is equal to 32. All right, do the other ones.
I say them all.
I remember this.
I hear it.
Okay.
So log
10 equals.
base a of x is equal to -5. So what is a? 10 to the what?
-5th.
Is equal to 0.00001. And that would be true, because that would be 10. And then 1, 2, 3, 4, 5 would be that. And down here, y is equal to log base a of x, a to the y. A is 8 to the 0. What's anything to the 0 power?
1.
So you are learning how to rewrite from a logarithm to an exponent, and from an exponent to a logarithm, you're talking about 2 to 3 questions on the test. So now you're up to 5 questions. 5.1, graphing vertical shifts, horizontal shifts of an exponent. 2, how to plug and chug on a calculator. 3, 4, and 5. These 2 questions right here. So you're up to a third of the test or a fourth of the test. These are not hard. They're not, you don't have to think a lot. You just have to know the properties. All right, graph log base 5 of x. Now,
Okay.
to graph this one, they should be showing you the change base formula. Okay. They're wanting you to change it because you cannot graph log base 5 because the calculator, and I'm going to go ahead and throw this out. I shouldn't be doing it this early, but you can't do log base 5. Okay? The only thing your calculator can do is log base 10, which is the LOG key, and log base E, which is the what key? Natural log key. That's the only 2 mathematical operations that your calculator can do. So if you see a log base 5, there's 2 things you can do. You can rewrite it, or you can change base. Change base is for later. So if you have a log base 5, you cannot do that in your calculator unless you either rewrite or what? Change base. Now we haven't done the change base formula, so I'm not gonna, so we're gonna rewrite it using the definition of a what? Logarithm. So here we go. We put our logarithm down here. So that's going to be y is equal to log base a of x, and equals a to the y is equal to x. What's a? 5 to the y is equal to x. Now, if you plug in x, you're going to get, or if you plug in y, you're going to get what? X. And what numbers do I always tell you to use for your x or your y? -2, -1, 0, 1, and 2. Even if you're pre-algebra, you're supposed to use those because they give you the negative, they give you the 0, they give you the positive, they give you more than 2, because that way if you mess up one, you got 3 or 4 others to lay on, so that's why you do 5. Now you plug those in. -2. Well, 5 to the -2, 5 to the -2 is 1 over what? 5 to the second, which is 1 over what? 1/25. 5 to the -1 is equal to 1 over 5 to the first, which is 1 over what? 1 over 5. Everybody with me? Now, you have to, now I don't know if you can do it on the calculator because with this one, I want you to do it like this because you need to understand what you're doing. But if you can do it on your calculator, you may have to change the differential on your calculator, and you could possibly do it through mode, I think, and you can change from a quadratic to a differential, I think, or something like that. But it's easier just to do this, okay? I probably won't ask you to do this on a test, but I will ask you to rewrite. Okay, so 0, anything to the 0 power is what?
1.
1. So you plug in 0, you get 1. 1, you're going to get 1/5, and 2, you're going to get 25, or not 1/5, you're going to get 5 because you flip it. Okay, so to make a long story short, you don't flip it, it's to the first power, second power. 5 to the second power is 25. So you plot those points, and you're going to get that function. Now remember, this is not y is equal to something x, or y is equal to the x. This is a reverse. This is an inverse. So if you wanted to check it to see, then you would say 5 to the x. Hold on. You would do 5 to the x is equal to y, like that, and that would be your inverse. Y is equal to 5 to the x. And we said that when you take and do 5 to the x, it's going to look like what? It's going to look like that. Okay? Well, it's going to look like the blue one, except it's going to be like that. So you're getting the inverse function there. And what did I tell you? I told you when you type in, when you do the rewrite, you're getting the inverse function. So that's a good problem. Not necessarily, I'm not going to ask you to graph it. I might, but I doubt it. I'll probably get you to rewrite that on the test. And of course, y'all can read the domain and range of these functions. I'm not going to, well, that changed. I didn't even touch it. That's nice. Okay? Explain how the graph of each. Now these you can do what in your calculator? Or you could sketch them. But I'm going to rewrite the second one. Y is equal to log x minus 2 plus 4. Somebody tell me what the horizontal shift is.
2
2 to the right. And what is your vertical shift?
4, up 4.
4 up. So these are all 3 test questions. This is just a horizontal shift of 3 to the what? 3 to the left. And this is the parent graph of log, only what?
Stretched.
It's going to be stretched along the what? X-axis, and it's going to be compressed along the what?
Y-axis.
The y-axis. So those are 3 test questions, and that's what I would ask you to do. Tell me the vertical, horizontal shifts. Again, the only thing we've gotten into algebra with logs is to rewrite. We haven't gotten into the real algebra yet. We're still doing vertical and horizontal shifts. There's the horizontal shift of 3 to the what? Left. Now, what are you using for an origin? You're using the x-intercept, okay? So here is the parent graph, and here is the 2 to the right, 1, 2, and how many up? 4. 4 up. And you'll see the next one is compressed along the x-axis and stretched along the y-axis. So that's why you see it kind of, let's see, this way and compressed. That's why it's squattier. It'd be squattier. Because it's compressed along this axis. Oh, me. And stretched along the x-axis. So that's why it's squattier. Again, you're comparing them to what graph? Your parent graph. Okay, that's what I just wrote down a while ago. Log base E is equal to the natural log. Does it matter which one you use? No. I use log, but sometimes I will use natural log. The properties do not matter. Is it a preference? Yes. It's pretty much whichever one you want to do. Pendleton, y'all up there, I only see one person. Somebody on the other side of the room say something.
Where?
I don't know why it's stuck there. Do me a favor. Turn it to the left a little bit. Keep going, keep going, keep going. That's good. Thank you. Darn, they put their laptops up. It must not be nothing good on.
They're working hard.
Yeah, they must not be nothing good on.
Y'all keep going, coming with pride.
Must not be nothing good streaming today. All right. Here they give us a Formula, natural log of x, they want you to graph it. Is it increasing or decreasing? Y'all should know that from graphing it on the calculator. What does it say in 2022? You look for 22. Is it years? Somebody look over it. Is it years since 2000?
Yep.
Yeah. So you look at x is equal to 22, and then use the graph to estimate when it will be 33%. So you look for y is equal to 33%, and you look for x. That is a test question that y'all all should be able to do. Okay, that is a graphing test question. So I'll probably see it on the homework, so we'll go over it when we go over the homework. Well, here it is. They graph it. Then you find where x is equal to 22. Where is it's increasing? Because what do we do? Left to right. What is our plane doing from left to right? There's our plane. What's the plane doing? It's increasing from left to right. So that's pretty simple. Y'all know why y'all know this is because we spent a lot of time in Unit 1 and Unit 2 going over all this. So you should feel good about yourself. And there is 22. Okay, why are they not showing you how to do 22? So this is x is equal to 22. There's nothing there. There. X is equal to 22. You plug and chug. You look on the table, or you do a trace with your calculator and find the answer to be 23.7. I don't care how you find x is equal to 22, what is y, you can do it however you want to on the calculator. Plug and chug, you can find it with the trace or you can find it with the table. I don't really care which one you do. Here, y is equal to 33, and find the what? Intersection point. Which we've been doing that since Unit 1 and Unit 2. Here is your basic properties. These are the numerical properties. Okay, they're on your sheet. Okay, they're on the sheet that I gave you at the beginning of the class. All right, let me check, see, because some of y'all might.
People gonna start convulsing.
Is it time for convulsing? All right, so we'll go ahead and shut it off right there, because I don't want Pendleton to hit their head on the floor or anything.